Hello everyone and welcome to our Python Data Science Workshop series. I'm Chi and today we will be talking about some fundamental concepts in Python, variables and operators. You can find today's notebook file under folder day 1 named 001 variables. And before we jump in, let's get a quick overview of what we will cover. So all programming languages, including Python, have three basic fundamental building blocks. That is variables, operators, and function. Today we will be focusing on the first two. And we'll start with numbers, looking at integers and float. We'll play around with some arithmetic operators, adding, subtracting, dividing. And then we will check out boolean operators, which help us to make comparisons. And we will also explore some handy built-in functions for working with numbers. After that, we will move on to strings, which is how Python handles text. We'll see some built-in functions again for strings and learn how to format our print statements to make them look nice. Again, along this tutorial, please feel free to pause and try to run some code by yourself to explore Python. Now let's begin by variables. So in Python, variables are used to create references to objects. You can think of them as containers that hold data, and they're assigned using the equal sign. We can take a look at our first code cell. So here we're trying to define two variables x and y, and we're passing two integer values to it. So integers, they are whole numbers without any decimal point. We can run this cell by click the play button above or press shift and enter together. And you might notice that nothing seems to happen when we run this cell. And that's because Python has stored these values for us, but it doesn't automatically display them. But we can verify the variable by printing them. So here we're trying to print both x and y. And we can see that if we run this cell, we can see that both x and y are printed and the value are also correct. Next, we can also define float variables, and float, they're short for floating point numbers. They're numbers with decimal points and are often used when we need more precision than just integers. Again, we can run this cell and check out if the variables has been created. And here we can see that C has been printed by Python. And the other good thing about Python is that it has a handful of built-in functions. And here we're introducing a frequently used function called type. It can tell us what kind of object we're dealing with. And this is incredibly useful when we are working with data and we want to know exactly what we're handling. So here, if we run this code, we can see that it returns the type of the variables to us. So x is an integer and a is a float, and we know this is correct since we just created them. Another thing is that we can run a lot of different arithmetic operations in Python, and this is just like you're using a calculator. So Python has the capacity to perform specific mathematic or logical manipulations. Here, this table are just the examples of the common tasks that we can run, and you can also feel free to practice this for yourself. So now let's try to do some math. So for example, here you can print, for example, x plus a, and you can see that the result is 2.0, and we remember that x is an integer before, but since a is a float, so Python is upscaling this variable, the newly generated variable, into a float to make it consistent. What you can also do is that you can do other mathematic tasks. For example, you can try to do a division, like b divided by c, and Python will also return us the result. So now moving on, let's talk about Boolean operators. Boolean operators are very common in Python, and these operators evaluate conditions between two operands and return either true or false. And understanding these operators is crucial for making decisions in your code. Here, this table is a quick rundown of the most common Boolean operators. So the double equals check if two values are equal. The exclamation mark followed by equals check if two values are not equal. And then followed by less than, greater than, and less than or equal to, and greater than or equal to. So let's see those operators in action. You'll notice that in our example, we'll use these operators to compare different pairs of numbers, and the output will tell us whether each statement is true or false. So now let's try to run this cell. And when you run this code in your Python environment, you can see that each line will evaluate the condition and print whether it is true or false. So for example, on the second command, we're trying to check if 87 is less than -2. And we know that this is false, and the result is also returning us a false. And so these simple examples demonstrate how you can use Boolean operators to guide the logic flow in your programs. A few tips to keep in mind. The first one is that always ensure that you're comparing compatible types. So for example, strings to strings or numerical versus numerical. And secondly, Boolean operators, they're fundamental in control structures like if statement, which we will cover in upcoming tutorials and we will apply a lot in future. And the built-in function are also very useful for some numerical variables. Here, we're introducing the is instance. It is used to determine whether an argument is in a certain class, and the result will be a Boolean value, so true or false. And here, if we try to run the first code, it is checking if 12 is an integer. And we see, if you run this code, we will see that result is true. And the second one is checking if 12.0 is still an integer value. And we will probably expect that the result will be false because it has a decimal with it. And what you can also do with this, that you can set or condition. So this command will check if 12.0 is either integer or float. And we know that 12.0 is a float type, so this will still give us the result of true. And next, here is just some few more examples. The command int parenthesis and float parenthesis, they are used to convert between data types. So we can convert either float to an integer, or we can do the other way around. And notice that when you are converting a float value into an integer, the int function will always round down the integer to the nearest whole number. And if you want to round a float number to the nearest whole number, then there is another function which is pretty straightforward. Round parenthesis, and then you can specify this number of decimal places by adding an integer as an argument to the round function. So for example, if I want to round the variable c and still maintain 3 decimal places, we can just add an argument after the variables with a comma. And we can see that C is originally in our data set, it is 12.3.782043. And this round command will round it into only 3 decimal points. And next, we also have a function called complex, and this is used to define a complex number. And in this tutorial, we will not using this type of variables, but then again, it is important to know that Python also has the capacity to handle them. So here we're defining that d as a complex variable 5 plus 2j, and the footprint d, we can see that it is coming as this complex, with formula and also variables with it. In the next, the final function that we want to introduce is the absolute. So you can use this to return the absolute value of the variables. So here it's pretty straightforward. Moving on, now we will introduce another very important data type in Python, that is string. So string are sequences of characters used to handle text data. And you can use either single quotes or double quotes to define strings. And the only difference between these two is that it is easier to use an apostrophe with a double quote. So here is how you can define. So the first one, we're defining my text using a single quote to wrap. This is a string text. In the second one, we're using a double quote to wrap my text too. This is also a string. And when printed, both strings will appear the same. And the flexibility will allow you to choose the type of quotes based on what's more convenient for you, especially if your string will contain quotes. And to use an apostrophe or single quote inside a string, the first thing you can do is to wrap up the string with a double quote, and then you can put the single quote inside the string. But if you're using a single quote, then you will need to use an escape character without ending the string prematurely. And the escape character is a backward slash. So here we're adding a backward slash before the single quote to represent the apostrophe. And if we print, we can see that the result is giving us the same text. What is Newton's first law of motion? And we can see that the apostrophe is maintained in our result. And just like numbers, there are also several built-in functions in Python that are built to handle the string data. So the first thing you can do is that you could use the string command to convert a number to a string. So recall that before we create a variable y and it is an integer, and now we can create a new variable called y_str, and using the string command to convert it from an integer to a string type. And we can see that by using the string command, the y_str, now the data type is converted into a string. And also we can use the plus operator to combine two or more strings. This is called concatenation. So here we are creating a new variable named s, and we're trying to concatenate Isaac with a space and also with a string Newton. And if we try to print this result, we'll see that the concatenated string is Isaac space Newton. Moving on, we can also use string dot upper or capitalize to convert all the letters of our string into uppercase, or capitalize just the first word. This is pretty straightforward. So we can uppercase Isaac Newton, and also we can capitalize Isaac Newton. And to check the result, we can see that the upper would upperscale all of the character, and then the capitalize will just capitalize the first character. So now moving on. Finally, let's look at formatted print statement. And this is super useful when you want to mix variables with your text output. And Python uses what we call a C-style formatting to create these formatted strings. It uses the percent operators, which allows you to insert values into your string to make your output more readable and dynamic. And let me break it down for you. So when we want to format a string, we'll use these special symbols as a placeholder. Here, %s is a placeholder for a string, %d is for integers, and %f is for float data. And the percent operator after the string is used to fill this placeholder with the actual values. Let's take a look at our example. So in this code, we're first defining two variables named city and years. So city is quintuple and years is 3 years. And on the first statement, we're using the percent %s as a placeholder for our city variable. And the percent after the string tells Python, hey, please replace that percent %s, the placeholder, with the value of city. And similarly, in the second print statement, we're doing the same, but with two placeholder now, with one for string and one for the integer. So it will giving both the city and years variable into the output format data. So if we print it, we can see that the first one is formatted as I live in Quintempo, which is the city. And the second one is I have lived in Quintempo for 3 years. Now we also include the integer value of years. Now let's move on. We can also group our variables by creating a tuple. So here we're having two variables first, which is a string, and age, which is an integer. And what we're doing here, we are creating a new variable called info, and that will be a tuple, which will group our two variables. And then we can use that in our print statement to fill in the placeholders with our sentences. So if we print this, we can see that the info is wrapping up the first and age and is replacing the tags in these sentences with the first to replace the percent %s and then age to replace the percent %d. And this will give us the output. My name is Achi and I am 27 years old. And note that this formatting style is really powerful because it lets us create dynamic output that can change based on our variables, which is super important when we are working with data that might change. And lastly, when we are working with float types of data, we can actually tell Python exactly how many decimal places we want to show in our output. So here, for the placeholder for float is %f. And in this code, we're first importing the math module, which will give us access to mathematical functions and constant like pi. And here we're defining a variable, which is the square root of pi. And in the first print statement, we're using %f as is, and this will give us the default number of the decimal places. However, in the second statement, we add a 0.2 before the f to tell Python that, hey, look, I only want to see two decimal places here. And when we run this, we will see that the differences. So the first line will show you a lot of decimal places, but the second line will only show you two decimal because we have specified how many decimals we want. And so this is really flexible because you can change the number to whatever you need and so on. But remember that this does not change the actual value that's in this pi square root variables. It just changed how we display it. And the full precision is still there if we need it later in our calculation. So this is very handy in Python. And lastly, I'll introduce a bit about the input function, which allows users to input data with a script or program. And this will give you like a prompt for users for input. And then the input is stored as a string, regardless of what you put there, either number or text. And therefore, if you write a function prompting the user for a number, you must be sure to convert the variables storing the input to an integer or a float. So here, we're trying to create a variables called month in with this input function. And if we run this code, it's asking us to give either like what we want to put here. So I'm gonna put maybe 6. And then if we hit enter, this will be passed or be assigned to Python and to be stored in the month in that variable. But we see that even though I gave a number here, the type is still saved as a string variables in Python. So that's why if you want to perform any mathematical calculation, you must first convert this variable into a numerical variables, either float or an integer. And lastly, there are also some built-in reserved keywords in Python that are native, and they cannot be used as variable classes or function. And one example is and you can see that when you type and, it will turn into green, and if you try to assign a value to this, it will throw you an arrow because the word and is reserved natively to Python. So if we want to create a variable, the variable cannot overlap with the keyword. And secondly, if we want to check what kind of keywords we have, so you can import keywords and then use keywords list, and this will print all the native keyword lists that cannot be modified or assigned in Python. And all right, we have covered a lot of today with variables, operators, and some basic data types in Python. Before we wrap up, I want to give you a quick peek at what's coming next. So in our next tutorial, we'll learn about more complex data structures starting with lists. And lists are super useful in Python. And here is how you can create list variables in Python. They are a way to store multiple items in a single variables. And we can do all sorts of things with lists. For example, we can check if something is in the list. And this is just a very simple example to show you what you can do with list. And we will talk more about it on our next session. But before we close today, I want to wrap up that remember variables are like containers for our data, and we can do math and make comparisons with our operators. And strings helps us work with text, and formatted print statements can also let us mix variables into our outputs nicely. So that's all for today. I hope you have enjoyed this introduction to Python basics. Keep practicing with what we have learned today. Thank you for your attention and happy coding. See you next time.